Start Team 50831. Rockets! When planning our robot design, we had a few different ideas on how to complete the mission. One idea was to build a bulldozer attachment to pick up and raise items. However, we soon realized this idea was impractical, so we didn't do it. Our other idea was to create an arm to pull, drag, and shift the missions and other objects around the board. We originally planned to do the following missions with the arm. The following missions are the pull-up bar, basketball, weight machine, and row machine. We had originally planned to do the following missions with the bulldozer attachment. The following missions are Basha aim and frame, cell phone, and tire flip. We, in a way, built the robot as we went on to different missions and didn't have much prior planning.
On our robot, we have two large motors that the wheels attach to so they can move. But the wheels wouldn't stay on, so we reinforced it with guards, and the guards also protect the wheels from getting stuck on objects or missions. The large motors are located on opposite sides of the hub with the hub on top of it. The next motor is located in the front part of the robot. This motor is used for the arm. The motor function was pointing up, so we could use a gear system to move the arm.
We have two sensors, one in the front middle and one in the back middle. Also, the sensors are used for the line following. We have a distance tracker so it can make the robot stop if it senses something close. We attached the distance sensor 3 ways so it would be secure. In the back of the robot, we had 6 regular Lego blocks and 4 Lego bars attached so that the robot would stay balanced. All the wires are pinned down with clips, so the wires are all over the place on the robot.
Our robot's programming starts off by going forward a few inches until the robot is definitely in the white space to the left of the black line on the right of the home. It then starts moving to the right until it sees less than 50% light. It then starts moving left until it sees more than 50% light. It sees the light percentage by using the front sensor on the robot. It repeats this process until the distance sensor senses an object less than 9.5 inches away from the robot. It then moves onto the treadmill. After this, we decide that it would be more efficient to bring the robot back to the home area to do the next mission than to spend our time coding the robot to return to the area we needed it to. After we took the penalty, we lined up the robot to the step counter and started a code that moved forward 42 centimeters to get it closer to the mission. Then it went forward 1 centimeter and then back a centimeter. It does this until it ends the step counter. It then goes back and turns left and travels under the pull-up bar. It then turns left and heads towards the dance party mission. It lands on the dance party mission and finishes the run. So this is a front view of our robot. This is our distance sensor, our front color or light sensor, our arm, our small motor that's attached to our hub for our arm, our left wheel and the large motor attached to the left wheel, the right wheel and the right motor attached to the right wheel, and the back color sensor. This is a view of our robot from the front, from the side, and from the back.